This is Sravanthi, working as Assistant Professor, Department of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss about calorific value of fuel. In this we discussed about types of calorific value, high calorific value and low calorific value, and theoretical calculation of calorific value by Dulongs formula. So first, what is the meaning of fuel? So already we know that fuel is a basic combustible substance. It contains main constituent is carbon. So during burning process, fuel interacts with atmospheric oxygen or air to produce heat energy. That heat energy is mainly used for domestic or industrial purpose. So fuel is a combustible substance. It containing main constituent is carbon. So during burning process, it produces heat energy. It produces heat energy during combustion of a fuel. So that energy is used for domestic and industrial purpose. So the atoms of fuel is carbon, hydrogen, sulfur, etc. So during combustion process, this combines with oxygen with simultaneously liberation of heat is known as fuel. If in case carbon present in this fuel, carbon reacts with atmospheric oxygen, then produce combustion product is carbon dioxide, and it releases 94 kilocalories of heat energy. If in case is present hydrogen, for example, so during burning process, it interacts with atmospheric oxygen, or during burning in the presence of oxygen, it produces water. It produces water, steam. So in this case, it releases 68.5 kilocalories of energy. So this heat energy is used for in domestic as well as industrial purpose. So what is the main source of fuel? So the main source of fuel is coal and crude petroleum oil. The main source of fuel is coal and crude petroleum oil. So these are stored fuels available under the earth crust. These fuels are stored fuels which are available under the earth crust, are generally called fossil fuels. So generally these fuels are obtained under the earth crust, that means plants and animal materials buried under the earth crust in a million of years in the usual absence of air. High pressure, then convert to fossil fuels. So the main source of fuel is coal and crude petroleum, which is obtained, which is stored fuels available under the earth crust, generally called fossil fuels. So because they were formed from the fossilized remains of plants and animals, just we discussed already, these are they are formed from fossilized fuels of plants and animals. So what is the meaning of combustion of fuels? So combustion is a process of rapid exothermic oxidation. It is a process of rapid exothermic oxidation in which fuel burns in the presence of oxygen. Fuel burns in the presence of oxygen with the evolution of heat and light. This process is called combustion or combustion of a fuel. So during burning process, fuel burns in the presence of oxygen to produce heat energy and combustion products. This process is called combustion of fuels. So in this mainly we discussed about calorific value. So the efficiency of fuel can be understood by its calorific value. That means if calorific value is very high, that fuel is a very good fuel. Its efficiency is high. So the efficiency of fuel, it can be understood by its calorific value. So what is the meaning of calorific value? So the calorific value of a fuel, it is defined as total amount of heat liberated. Total amount of heat liberated when a unit mass of fuel burned completely. How much amount of heat liberated during 1 unit mass of fuel is burning. That is called calorific value. So here 1 unit mass of fuel means, for example, 1 gram or 1 kg. So for example, 1 gram of fuel burning. So in this case, how much amount of heat liberated, that is the calorific value of the fuel. So combustion is a process. During combustion process, that means fuel burning in the presence of oxygen, then produces heat and light. That process is called combustion. So the efficiency of fuel, it depends on the calorific value. its calorific value. So what is the meaning of calorific value? So in this calorific value of fuel are defined as total amount of heat liberated, or how much amount of heat liberated during a 1 unit mass of fuel is burned completely. So 1 unit mass of fuel means 1 gram, for example. So 1 gram of fuel burning, in this case how much amount of heat liberated, that is called calorific value of fuel. So there are two types of calorific values, high calorific value and low calorific value. High calorific value and low calorific value. So high calorific value, it is also called as gross calorific value, GCV or HCV, gross calorific value. So it is defined as how much amount of heat evolved. So it is defined as amount of heat evolved when unit mass or volume of the fuel is completely burned. How much amount of heat liberated when a unit mass of fuel is burned. So actually definition of calorific value. So that heat we consider in this, and also we can consider combustible products are cooled to room temperature. Combustion products are cooled to room temperature, that also we can consider. So how much amount of heat liberated during 1 unit mass of fuel is completely burned, and also we can consider latent heat of vaporized water, that means combustion product cooled at room temperature. The temperature also we can consider in this. So that is called high calorific value. And what is the meaning of low calorific value? So low calorific value, it is also called as net calorific value, LCV or NCV. So it is defined as amount of heat evolved. Amount of heat evolved when a unit mass or volume of the fuel is completely burned and combustible products are permitted to escape. Here we cannot consider latent heat of vaporized water. Only you can consider how much amount of heat liberated during 1 unit mass of fuel is burning. That is actual definition of calorific value. Only that temperature, that heat energy only considered. So that is called net calorific value. So usually therefore net calorific value is always lower than gross calorific value, because in this net calorific value only we can consider how much amount of heat liberated. That heat only we considered in this. But in this gross calorific value, we can consider how much heat energy liberated when a unit mass of fuel burning, and also we can consider combustion product cooled, that means latent heat of vaporized water. So that's why therefore the net calorific value is usually lower than, net calorific value is lower than gross calorific value. So here some of the fuels burning in the presence of oxygen. So in this case how much amount of heat energy liberated, that means what are the calorific values of the fuels. For example, here we are taking cow dung cake. So during burning of this cow dung cake, it produces how much amount of heat energy? 6,000 to 8,000. 6,000 to 8,000 kilojoules or kilocalories of energy released. For example, during burning of wood. So what is the calorific value of wood? 17,000 to 22,000. And coal, in this case it produces 25,000 to 33,000 kilocalories of energy, heat energy liberated. During petrol, so burning of petrol, in this case it liberates 45,000 kilocalories of heat energy. And kerosene, its calorific value also same, 45,000 kilocalories of energy liberated. Diesel, 45,000. And methane, it produces 50,000 calorific heat energy. And CNG, compressed natural gas. So during burning of compressed natural gas, its calorific value is 50,000. And LPG, liquefied petroleum gas, it produces also 55,000 calorific value. Its calorific value is 55,000. And biogas, during burning of biogas, what is the calorific value of biogas? 35,000 to 40,000. And hydrogen, it produces 1,50,000. So for example, if the if burning these fuels in the presence of oxygen, it produces these calorific values. So what are the units of calorific value? So generally the quantity of heat can be measured by the following units. There are 4 types of units measured for using for this calorific value. So here calorie, kilocalorie, British thermal unit, centigrade, heat units. There are 4 units of calorific values. The quantity of heat can be measured by following these 4 units of calorific value. So what is that? Calorie, kilocalorie, British thermal unit, centigrade, heat unit. So what is the meaning of calorie? So it is defined as the amount of heat required. Amount of heat required to raise the temperature of 1 gram of water. 1 gram of water, 1 degree centigrade, that means 15 to 16 degrees centigrade temperature. So how much amount of heat required to raise the temperature of 1 gram of water is called 1 calorie. It is called calorie. It is defined as how much amount of heat required to raise the temperature of 1 gram of water. So here it is called calorie. Next one is kilocalorie. Kilocalorie. So it is equal to 1000 calories. So calorie means how much amount of heat required to raise the temperature of 1 gram of water. So 1 kilocalorie means it's equal to 1000 calories. It's equal to 1000 calories. So here it may be defined as the quantity of heat required. The quantity of heat required to raise the temperature of 1 kilogram of water. How much amount of the quantity of heat required to raise the temperature of 1 kilogram of water through 1 degree centigrade. Through 1 degree centigrade. So this 1 kilocalorie equal 1000 calories. 1 kilocalorie equal 1000 calories. Next, third one is British thermal unit. British thermal unit. So it is defined as, here also same, the quantity of heat required. The quantity of heat required to raise the temperature of 1 pound of water. To raise the temperature of 1 pound of water through 1 degree Fahrenheit. Through 1 degree Fahrenheit. This is the English system unit. So that means here 1 British thermal unit is equal to 252 kilocalories. That means 1 kilocalorie equal 3.968 British thermal unit. British thermal unit. And last one is centigrade heat unit. So how can we define this centigrade heat unit? So it is defined as the amount of heat required to raise the temperature of 1 pound of water to 1 degree centigrade. It is the amount of heat required to raise the temperature of 1 pound of water to 1 degree centigrade. So what is the relation between 1 kilocalorie? It's equal 3.968 British thermal unit, and it's equal how many centigrade heat unit? 2.2 centigrade heat unit. So what are the units of calorific value? It is measured by using 4 units: calorie, kilocalorie, British thermal unit, centigrade heat unit. So most commonly we are using calorie or kilocalorie. So what is the meaning of calorie? How much amount of heat required to raise the temperature of 1 gram of water. To raise the temperature of 1 gram of water. So what is the meaning of 1 kilocalorie? How much the quantity of heat required to raise the temperature of 1 kilogram of water. 1 kilogram of water. Usually we are using these units calorie and kilocalorie used for quantity of heat measured in simply we are using calorie and kilocalorie. So 1 kilocalorie it's equal 1000 calories. Now discuss what are the types of calorific values. So what is the meaning of calorific value? How much amount of heat liberated during 1 unit mass of fuel is burning. Here 1 unit means 1 gram or 1 kilogram. So in this case, how much amount of heat liberated during combustion process during 1 unit mass of fuel is burning. That is called its calorific value or calorific value of fuel. So there are two types of calorific value. One is high calorific value and another one is low calorific value. So what is the meaning of high calorific value? So it is also known as gross calorific value. It is also known as gross calorific value or high calorific value. So it is defined as the total amount of heat produced. It is defined as total amount of heat produced, and when a unit quantity of the fuel is completely burned and the products of combustion are cooled to room temperature. So what is the meaning here? How can you calculate the high calorific value? For example, fuel is burning in combustion chamber. This is a fuel burning in this combustion chamber. For example, it is a closed combustion chamber. It is the closed combustion chamber. So during burning process, this fuel it produces gases. It evaporates gases, steam. So during burning process, the combustion products or gases are evaporates, but it is a closed combustion chamber. So in this case, the steam, that means during combustion products are cooled. So in this case, the steam or gases are condensed back into this coal sample or in this combustion chamber. So in this case, it produces latent heat. It produces latent heat. So that heat also we can calculate, we can consider in this calculation of gross calorific value. So what is the meaning of gross calorific value? It is defined as total amount of heat liberated when a unit mass of fuel is burned. So in this case, for example, 1 unit and 1 gram of fuel is burned in this combustion chamber. It is a closed combustion chamber. So during heating process, it produces vapors. Generally, it is a closed chamber. So in this case, these vapors are, when we cool combustion product, this is condensed back into this combustion chamber. So in this case, it liberated heat is called latent heat of vaporized water. Latent heat of vaporized water. So that is also we can consider in this calculation of gross calorific value. So here, what is the formula we are using here? So high calorific value or gross calorific value. High calorific value or gross calorific value, it's equal heat liberated. During combustion process, how much amount of heat liberated. Plus latent heat of vaporized water formed. That means when we cool this combustion product, the gases of steam condensed back in this combustion chamber. So that it also considered, that is called latent heat of vaporized water is formed. So for example here, when the fuel containing hydrogen, if in case fuel containing hydrogen, so during burning process, so the hydrogen is converted into steam. The hydrogen is converted into steam. So if the combustion product are cooled to room temperature, so the steam gets condensed into water. So just now we discussed already. For example, this is a closed combustion chamber. This is a fuel during burning. So during burning process, if in case hydrogen present in this fuel, so during burning process it produces steam. It produces water vapor, that means steam. So during combustion, cooled this combustion product. So here see, if the combustion products are cooled to room temperature, so in this case the steam gets condensed into water. That means the steam reverse reaction. The steam condensed into water. Here this is a steam during cooling of combustion product at room temperature. So this condensed steam, the steam is condensed back into water. So and latent heat is evolved. So in this case it evolved, latent heat is evolved. So the latent heat of condensation of steam is also included in this GCV. That's why this GCV value is always greater than net calorific value, a lower calorific value. So for example, here what are the reactions takes place if in case fuel containing hydrogen. So during burning process, it produces steam. So in this case, it liberates energy, that heat is here heat liberated during burning of fuel and also cool at room temperature. So this steam is condensed back into water. So in this case, it released latent heat of vaporized water. So that is also we can consider here. So what is the formula here? HCV equal heat liberated. That means how much amount of heat liberated during 1 unit mass of fuel burn plus latent heat of vaporized water formed. That means when we cool this combustion product at room temperature, so in this case that gases steam or the vapors condensed into water. So that heat is called latent heat of vaporized water. So that is also considered here. So in this way we have to calculate the high calorific value or gross calorific value. So this value is always greater than net calorific value or low calorific value. And second one is lower or net calorific value, NCV or LCV, lower calorific value or net calorific value. So how can we calculate this net calorific value? Total amount of heat liberated. Total amount of heat liberated when a unit mass of fuel is burned. Actually, this is the definition of calorific value. What is the calorific value? How much amount of heat liberated when a unit mass of fuel is burned. So that is called calorific value. Here lower calorific value, how can you define this one? Total amount of heat liberated when a unit mass of fuel is burnt completely in air, in the presence of air or oxygen, is called lower calorific value. So that means in this case we cannot consider latent heat of vaporized water. For example, fuel is burned in this combustion chamber. Fuel is burned in combustion chamber. This is the open combustion chamber, for example. Open combustion chamber. So during burning process, it produces vapors. So this vapors, the steam will evaporate. Steam will evaporate. That means we cannot consider here latent heat. We cannot cool combustion product at room temperature. That means we cannot consider this latent heat. So that's why, for example, this fuel is burned in open combustion chamber. So during heating process it produces vapors. This is an open chamber. That's why these vapors are evaporate in the atmosphere. So in this case, we can consider only how much amount of heat liberated when a unit mass of fuel is burned in the presence of air or oxygen. It is called low calorific value or net calorific value. So formula is LCV equal HCV minus, HCV means high calorific value. So HCV minus latent heat of vaporization of water produced. Latent heat of vaporization of water produced. So it's equal to HCV minus mass of hydrogen. Mass of hydrogen into 9 into latent heat of vaporization of water. So what is the meaning? This mass of hydrogen into 9 into latent heat of vaporized water. That means we can consider only how much amount of heat liberated when a unit mass of fuel is burned. So how can you calculate this LCV? For example, 1 part by weight of hydrogen. You see the reaction. So 1 part by weight of hydrogen. It produces 9 parts. 1 part by weight of hydrogen produces 9 parts by weight of water. 9 parts by weight of water. So that means latent heat of steam is here 587 calories per gram. This value is fixed 587. Practically it is proved that. So how much amount of latent heat produced? Its value is 587 calories per gram. So here mass of hydrogen is 1 and 9 is the 1 part by weight of hydrogen produces 9 part by weights of water, that is steam. So here we are taking 9, and latent heat of vaporized water, its value is 587 calories per gram. So NCV equal, what is the formula? Gross calorific value minus 9 by 100 H. Here 9 is the, you see here, 1 part by weight of hydrogen produces 9 parts by weight of water. So that's why you are taking 9. It produces 9 parts by weight of water, and here by 100 into H means percentage of hydrogen present in fuel. Here where H is the percentage of hydrogen present in fuel, and into, it is multiplied with 587. 587 is the latent heat of vaporization of water. Value is the 587 calorie per gram. So how can you calculate this lower calorific value? So or net calorific value. So NCV equal HCV minus 9 by 100 H into 587. So in this case we consider only how much amount of heat liberated when a unit mass of fuel is burned. We cannot consider latent heat of vaporized water. So that's why we can minus this latent heat of vaporized water from this gross calorific value. So your formula is NCV equal GCV minus 0.09 H into 587. Here H is the percentage of hydrogen present in fuel, and here 587 is the latent heat of vaporization of water. So in this way we have to calculate the gross calorific value and net calorific value. Now let's discuss Dulongs formula. So theoretical calculation of calorific value by Dulongs formula. So this formula, Dulongs formula, clearly explains theoretical calculation of calorific value. So what is the formula? Dulongs formula for the theoretical calculation of calorific value is, for example here, gross calorific value or high calorific value. So it's equal, what is the formula? 1 by 100 into 8080 carbon plus 34,500 H minus O by 8 plus 2,240 sulfur kilocalories per kg. This is a formula used for the theoretical calculation of gross calorific value. It's a Dulongs formula for gross calorific value. So in this 8080, generally in this fuel it is present which type of elements? Which elements present in this fuel? Carbon, hydrogen, oxygen, sulfur. Generally these elements present in fuel. So here 8080 means calorific value of carbon is 8080. Theoretically, the carbon calorific value is 8080, and 34,500 calorific value is the hydrogen. Calorific value of hydrogen 34,500, and sulfur calorific value is 2,240. So theoretical calculation of calorific value by using Dulongs formula. So according to Dulongs formula for high calorific value, HCV or GCV it's equal 1 by 100 into 8080 carbon and 34,500 H minus O by 8 plus 2,240 sulfur. This is the formula used for high calorific value. So here where carbon and hydrogen, oxygen, sulfur present in the, this represent the percentage of the corresponding elements in the fuel. How much percentage of these carbon, hydrogen, oxygen, sulfur present in the fuel. And here it is based on assumption that the calorific value of carbon, hydrogen and sulfur are found to be really, just now discussed already, the calorific values of carbon, hydrogen, sulfur are 8080, 34,500 and 2,240 kilocalories when 1 kg of the fuel is burned. When 1 kg of the fuel is burned completely. If 1 kg of fuel is burned, in this case, the how much amount of calorific value, how much amount of heat energy released? 8080, 34,500 and 2,240. That is indicates calorific values of carbon, hydrogen and sulfur. during 1 kg of fuel is completely burned. In this case, it releases this much of energy. So, however, all the oxygen present in the fuel is assumed to be present in the combination with hydrogen in the ratio. The hydrogen present in the fuel, the total oxygen percentage present in the fuel, it is assumed, it can be calculated to be present in the combination with hydrogen in the ratio. Usually we know that hydrogen during burning process, it interacts with oxygen, then produces steam. So that's why we can calculate the percentage of oxygen present in fuel. It can be calculated the combination with hydrogen in the ratio. So what is the ratio? Hydrogen and oxygen as 1:8 ratio. 1:8 by weight. So the remaining hydrogen, the surplus hydrogen available for combustion is H minus O by 8. H minus O by 8. We cannot calculate individually oxygen percentage present in fuel. So that's why we are taking here how much amount of oxygen present in this fuel. It can be calculated the combination with hydrogen in the ratio. Generally, hydrogen and oxygen ratio is 1:8 by weight. So the remaining hydrogen available in the fuel, it can be calculated by using this formula H minus O by 8. So here, how can we calculate the net calorific value? So NCV or LCV, it's equal HCV minus 9 by 100 H. So here 9 means 1 part by weight of hydrogen burns, 9 part by weight of steam, water vapors produced. So that's why we are taking here 9 by 100. Here H is the percentage of hydrogen. H is the percentage of hydrogen in fuel. H is the percentage of hydrogen in fuel. And 587 is the latent heat of vaporization of water. Vaporization of water. So this is the formula. So according to Dulongs formula, the theoretical calculation of calorific value of Dulongs formula. So by using this here, according to Dulongs formula, gross calorific value, how can we calculate? So by using this formula, 1 by 100 into 8, here 8080 and 34,500 and 2240 are the calorific value of carbon, hydrogen, sulfur present in fuel during 1 kg of fuel burning completely. In this case, it releases this much of amount of heat energy. So it is theoretically proved already. And so oxygen, how can you calculate oxygen percentage? Individually, it cannot possible because during burning process, it produces a water vapor, steam produced. So that's why we are taking here H minus O by 8, 1:8 by weight. We're taking. So how can you calculate NCV value present in this fuel? So NCV or LCV is equal HCV minus 9 by 100 H into 587. Here H is the percentage of hydrogen present in fuel and 587 is the latent heat of vaporized water. So latent heat means during combustion product, combustion product is cooled at room temperature. In this case, it produces heat that is called latent heat of vaporized water. That is also we can consider in this LCV, but in NCV we can remove from HCV. For example, how can we calculate the carbon, hydrogen, sulfur, nitrogen, which are fuels present in fuel? These elements present in fuel by using Dulongs formula. For example, here calculate the gross and net calorific values of core sample having the following composition. For example, here carbon present 85% in this fuel. Carbon percentage is 85 and hydrogen percentage is 6% and oxygen is 2% and sulfur is 3% and nitrogen 1%, ash 3%. So these percentage, these elements present in this fuel. So how can we calculate the gross calorific value or net calorific value? So by using this Dulongs formula of high calorific value. So what is the formula? HCV equal 1 by 100 into 8080 carbon plus 34,500 H minus O by 8 plus 2,240 sulfur calories per gram. This is a formula used for the high calorific value of a fuel. So here this 8080, 34,500 and 2,240 is the calorific value of carbon, hydrogen, sulfur during 1 kg of fuel burned completely. So it produces these calorific values of carbon, hydrogen and sulfur. So here in this formula you can substitute the percentage of carbon, hydrogen, sulfur. So carbon percentage given here 85. So 85 carbon percentage is 85 in this fuel. And hydrogen percentage is 6 percentage. So we can substitute in this formula. And oxygen percentage is 2. So we can substitute in this formula. And sulfur percentage is 3. So all these values, all this percentage of carbon, hydrogen, oxygen, sulfur percentages substitute in this formula. We can calculate the high calorific value of the fuel. So what is the final answer? 8,918.95 calories per gram. And how can we calculate the net calorific value? So what is the formula? LCV is equal HCV minus 9 by 100 H into 587. Here 587 is the latent heat of vaporized water value and H is the percentage of hydrogen present in fuel. So here HCV value already just now we calculate that 8,918.95 minus 9 into hydrogen percentage is here 6. So 6 by 100 into 587. So net calorific value is 8,601.97 calories per gram. So in this way we have to calculate the high calorific value or net calorific value of fuel. So in this session we learned about what is calorific value, how many types of calorific value and what are the units of calorific value. So just now we discussed already what are the units of calorific value: calorie, kilocalorie, British thermal unit, centigrade heat unit. And also we discussed how can we calculate high calorific value and net calorific value present in fuel by using Dulongs formula. I hope understood all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.